Hi guys, welcome back to the next video. In this video, we are going to talk about multiple troubleshooting, and basically we are going to trouble the all those concepts which you have seen so far. That's what we're gonna do right now in this video. So to begin with, what is that we're going to do is like we're gonna create a directory under the storage called P12. So that's what the reference to be in your GitHub as well, part 12. In that we are going to create multiple steps here. So step one is basically the same kind of step, which is creating the P12 storage persistent volume 3 .yaml. So this file, you can just copy paste the persistent volume. As of now, we are looking at the static volume. We have not gone to the dynamic volume so far. So which means that a static value means that you specify the volume while you specify the persistent volume. So you kind of keep a limit that in which it cannot actually load any files beyond that limit which you are specifying there. So that's what static volume is all about. Static persistent volume is all about. So you can see that I'm giving a maximum utilization of 5 GB, even though I have multiple GB available, but I'm restricting myself for this particular persistent volume to have only 5 GB as max. And here I'm giving access mode as rewrite many. So this is basically the constraints over here. So what I'm going to do is like rest of it all same, so there's not much difference to discuss about. Then I'm just going to create another file over here called storage PVC3. So it's going to be persistent volume claim 3, and this file is gonna have the step 2. You can copy paste that. So this file is gonna be a little different. Now this file is created in a wrong way, I know that. So storage class name is going to be manual, so there's not much into its dynamic. As I told you, this is going to be static. Access mode is wrong because there in the PV we have given read write many, here just once, and the storage volume is 1 GB rather than 5 GB. So for this persistent volume claim to work, you need to make sure that you have the exact same configuration as per the PV, and this one doesn't have that. So let's save and quit this file. Let's create the third file, which is going to be storage pod. I think it's 10. Let me check the last version. Yeah, 10 it is. 10.yaml. So YAML. This file is going to have the configuration, a lot of configuration actually. It's going to have most of the stuff which we discussed so far. So it's going to have a service, node port service, which is going to have the URL for us to enable us to browse it through both replicas. So we're going to create 2 replicas. So we will have a common cluster URL for us to browse the application. It's going to have, let's go from the beginning. It's going to have the deployment as well. As I told you, 2 replicas here. NFS app is the pod name, and that's the selector. And here we are going to use multiple containers here. First container is going to be the name of the container, OS container. It's going to write the date and the host name into the index.html file in the var HTML location. That's where it's going to write. It's going to have NFS volume. Do remember that before executing this, make sure you remove all the files from your var mnt, because if you have created a file from the local file system and you're trying to append it within the container, it's not going to work because you don't have the right permission for root, because all those things which is going to be created under the container, it's going to create with nobody. And if you have created the index.html file already with your mnt from your manager server, it will have created with root, so it won't have the permission to update it. So you'll get a permission denied error. So I will also show you that. Okay, so the next thing is the volume mount over here for this particular volume. So it's just NFS mount. NFS volume is the name of it, and where HTML, that's where it's going to update your index to HTML with the date value and the host name value. That's a basic operating system here, which is Alpine. Here we are using readiness probe to make sure that this particular container goes out of ready state in case if this HTML file is not accessible or anything wrong happens with this index to HTML file. And these are the basic parameters which we already discussed in the probe section. And then we have another image here called Nginx, and this is loading an image Nginx latest. And here you have the NFS volume mount here. And so this NFS volume mount is going to talk about where user share Nginx HTML. So it's a default document root of your Nginx service. And here you have two probes configured, liveness and readiness probe, which is going to be gathering HTTP GET for the root path for port number 80, both liveness and readiness probe. So there's a reason why we're enabling it. Finally, we have the volume definition, which is going to be the name of the volume NFS volume, and then the persistent volume claim, which we're going to use as claim name NFS-PVC. So that's the name we have defined for your PVC. And then the service definition. All right, sounds good. So now we have the complete configuration, set of configuration for us to go over. So I'm just going to first fix the problems here. But before that, just rm-rf mnt nfs. Oh, sorry, I deleted the folder itself. Don't do that. I only remove the content inside it. So mnt nfs. So this should actually get the service export fs. Let's just see if it's working fine. Yeah, it's working fine. So I'm just going to touch this file inside this mnt nfs index.html. So as I'm creating this file as a local user and I'm on the server, so you see that it creates with root, right? So you need to change mode 777 for your mnt nfs as well. So now that I've done that index.html, so you will see errors while it basically brings up. So I will show you that error as well. So let's go ahead and work on this. Yeah. So firstly, kubectl apply -f p12 storage pv3.yaml. So it has created my persistent volume over here, as you can see. So it is created with the read-write mini, and this is the available status right now. So I'm just gonna apply the PVC3 as well. Now the PVC3 has gone to a pending status. What this means is that it's not connecting with any of the PVs which is available, because there could be some, or that the value could have mismatched for it. So let's just do a kubectl describe the persistent volume claim. You can see that warning provision failed 3 times. And the persistent volume controller, from the persistent volume controller, it says like manual not found. So it says storage class manual not found. So if you see this one, it is looking for the storage class manual, but then it's there. Just that other things are not matching for it to work. So let's just do vi, go to PVC3, and then make this to many. But still you will have the same problem when you rerun this apply PVC3 again. I'm sorry, just have to remove it. kubectl delete PVC. Then let's apply it again. All right, so now you can see that it is bounded even though the GB is wrong. So here the PVC3 still has 1 GB of data space, but still when it is bounding to that, did I run the right command? Yeah. So when I bounded to that, it changed its capacity to 5 GB. instead of 1 GB is what mentioned in your configuration file. Because when you're mounting it to a specific PV, as this is a static one, it's going to go and align to whatever the PV says. If you want to do a dynamic one, the difference between static and dynamic is very simple. Yeah, static one has a amount of GB specified in the PV value, so which means that the persistent volume claim can only use that much value. In terms of if you're using a dynamic value, there'll be no limit specified in your PV, right? So your persistent volume does not have any limit. Only the PVC will have a limit, which it can use. Depends on the customer. Like your pots are its customer. So basically, you can determine for every PVC you can give, because you can have multiple PVC working with multiple different storage capacity, and those multiple PVCs can provide multiple different services and two different pots. So that's the major reason. So we will talk about in detail like how we can classify in terms of dynamic rather than like having a fixed assigned PV right now. So in that time, I will be telling you more on that. All right, so now that has gone to bound state, even though we have explicitly given 1 GB over here, but still it has bounded. All it needs is the read write many over here. Access mode has to match. All right, so going on with the next one, which is going to be executing our the pod one for the deployment. So just let's go on to it. Apply -f P12 storage pod 10. It's actually deployment, sorry to name it as pod. Well, so it is throwing up an exception over here. 8090 provider is not in the valid range of 30,000 to 31,000. So we may just have to redeploy this again. So let's just do kube let. I've already run this command, so I'm just gonna go over here and do this change from this one. So let's just do a way on this pod. I forgot that I gave this port number 30,000. So you unclude this file. I'll just modify that on your page as well. 30,000. There you go. It's terminating. It's taking a bit of time. It always takes a bit of time when you terminate something which is running, which has like multiple containers within itself. So let's just go ahead and apply this again one more time. All right. Now, there would be initial delay because of the readiness probe. So you will see one container coming up and second container coming up. And there would be a delay of it to come up. Two reasons for that. One, you have multiple containers. Second, you have readiness probe, which basically needs to make sure that the containers are ready before it goes to the ready state. So now everything is working fine as it should. You have a readiness probe for your HTTP server, but then is the website working? That's the first question. So curl and the IP address of your Nginx service. So here's the one. This is the one that's Kubernetes. Yeah. So when I give this, I get an empty page. Why? Because that's what it is. So if you go to MNT, if you go to NFS and then do index.html cat, you will see nothing in there. But we have asked a container to keep on writing the date and the host name, right? That's what is happening over here, but it seems like it's not working. So let's just do quickly. kubectl logs, the name of the container, and you can see that you're getting permission denied over here. So when it's trying to write it, it's not able to write this mntnfs, this file. It has root privileges. That's the reason. All you have to do to make this work is basically remove this index.html file. So this, when you remove this, it will automatically create it through container and push it to the server. So you can see that the new file is created now. So if you just get this file, you can see that already both the containers have started to write the output over here. So output is very simple: date every 10 seconds, and the host name. Host name is this one is 57 okay, this writing first, this is worker node 1, and XZH, that's worker node 2. So likewise, you can see that the content is getting updated every 10 seconds. So this gives us a good opportunity for us to go and work with this particular particular website. So let's just try the curl command again. Sorry. So I'm just running it from the memory. So curl with the IP address of your cluster IP. Node IP, node port, which is over here. So you can browse it individually as well, but there's no point because it's going to show you the same content because it's from NFS. And you can see that pretty much works fine. And what happens if NFS crashes? That's the next question. So if NFS crashes, well, let's see. So let's just do systemctl. Systemctl. NFS hyphen. I think NFS hyphen service dot server dot service. I guess. I think I have to give stop. NFS server dot service. Yes, there you go. That's a command. So if I stop the NFS service, you can see that there's no impact over here, right? But there is impact over here because of thanks to the liveness probe and the readiness probe. So here kubectl describe and the pod name, you can see that it has gone, instead of 2 out of 2, it has gone 1 out of 2, and soon it should go, it should go to 0 out of 2 because none of the pods should be ready. So I'm just waiting for that to happen, see if it happens. You can see that 0 out of 2. So both have been gone out from the ready state, and one we have liveness probe, which will restart the service to see if it fixes. So that restart may happen anytime now because it needs to go through a specific number of times. So you can see this output over here. The HTTP probe is 404 and then 403. So these were like getting before us because of the permission issue. And then later we were able to see this exception. So you can see it is killing. It is doing the test-e. So this is what we have given on our, readiness probe to check whether that service is running or not. And then you can see this one over here that it's not able to get the page because the NFS is gone. So you won't be able to access this file system. This you can see it because you are accessing it from the master server. So it's just a directory for you. But when you do kubectl exec -it pod name and then sh or bash or whatever, and then go to where html. So this is in the OS container. You see that, right? So when I go to where folder, it kind of gets stuck. It kind of got stuck because the folder it's not there. So that's the problem. The whole session is stuck actually. Damn it. So as you can see, the entire session is stuck. So all I have to do right now is log in from another one. See, it was all fine until I hit that where HTML. So that's where the NFS mount actually took place. So SSH manager 1. So I just need to do -l kube. So now I'm in the manager. So I'm just gonna systemctl start NFS-service server.service. So now that I've started it, you can see that it just gave me back my console, or else my console was like lost to me. So even that got hung. So this is what serious it is when your services goes off, and you can see that my pods are recovering, and it's right now it's 2 out of 2, and there was 2 restarts done, as you can see over here in the past while it was down. So now this troubleshooting proves that your liveness probe and readiness probe is so critical for every deployment you do, because that's gonna keep on verifying whether your application is actually working or not, and basically take actions when your application gets to a hung state. And NFS is a very good example, because if this particular manager server goes down, then NFS goes down with it, and the same thing happens over here. Now, another thing I want to show you when the NFS service goes down is that you will not be able to delete any of these services. So, for example, let me delete the pod. You can see that I'm deleting not the pod, but the deployment. I'm deleting the PVC, right? I'm deleting the PV as well. You can see that everything goes to terminate status and then gets hung there because of the dependency which it has on your on your NFS service. So let's see if these gets terminated after your pod gets terminated. It all goes to a hung state in which it will not recover until your NFS comes back, because it's all dependent on it. So there is always these guys put up created a thread with the NFS service, and that thread is hung right now. And the only way to recover the thread is either it gets timed out eventually, which could take hours. We don't know what's the timeout value there, or you just have to bring back the NFS service. So just give a start over here and fix the underlying problem with the NFS service, and then when the service comes up, you can see that it just clears off. These are something which other trainers wouldn't share with you, because these are real-time scenarios which is not mostly covered on any trainings. And all they talk about is some configuration, and they read the configuration, they write it, and they make most of the time by doing time pass on the videos. But these videos are to the point. I tell you all the real-time troubleshooting which I face on a daily basis as a system reliability engineer. Your review means everything to me, and I'm creating more contents than what is promised to you. So more projects will be coming on sooner or later, where the real-time scenarios where I want you to fix something for me in a real-time scenario, and this is all something which you can do it in your laptop itself, because all these are run in my laptop. I'm not spending a penny here for any of the cloud services or whatever. Thanks guys for your time and patience. If you have any questions, please leave it on the question section.